In this part of the tutorial, we're going to introduce the integer type variable in the iOS platform. So first we're going to declare and initialize some integers by giving them values, and then we're going to change them later on in the code. And we're going to solidify the examples using real-world examples of bank accounts, and we're going to demonstrate some arithmetic operations that we can perform with the integers that we've declared and initialized. So this part of our tutorial will deal with integer variables. So these are number variables that cannot be decimals but are limited to a certain range. However, this range is very large. It's well over 2 billion. So for our sakes and purposes, we can represent any non-decimal number as an integer. So let's show you what one looks like now. So this is a variable of type int or integer, and let's just call this number, and we'll give it the value of, let's say, 10 to start off with. So notice this number here is in kind of an orange color. This is how basically all numbers are going to be represented. So if we have a 1, we have a 6, we have 100, all of them are in orange. Now again, this is an integer rather than any other number type because it has no decimal place. It could be negative or positive if we want it to be. And that's what an integer looks like. So let's go ahead and print this out right now, just to make sure that everything's as it should be. So if we print out number, and then we need to convert this again to a string, because the label will only take in strings as text input. So let's go ahead, and that was still running, so we'll stop it first, and then we'll run it. Let's choose the iPhone 5S again. So while we're waiting, here we go, and we get 10 being printed. Alright, now what we can do with integers is we can perform a lot of arithmetic with them. So we can perform operations such as addition, subtraction, division, multiplication. We can do a lot of different things with them. So let's go ahead and we'll call this number 1, and we'll call this integer number 2. And let's give this a value of 20. So what we'll do is we'll do some basic math down here. Let's say number 1 plus number 2. And what we'll do is we will assign, let's say, number 1 equals number 1 plus number 2. So what I'm doing here is I am reassigning the value of number 1 to equal whatever it previously was plus number 2. So now it's taking the previous value of number 1, which was up here, a 10, and it's adding it to number 2, so that will be a 20, so we should have a 30, and we're storing that into number 1. So we're reassigning number 1 to be the results of this addition. So if we print out number 1 again, so we'll stop that simulator. We'll say run with the iPhone 5S again, and we'll just wait for it to load here, and we get 30 being printed out because that's a result of 10 plus 20, and we're storing it back into number 1. Now we can assign some real life values to these if we want. So let's call this something a little more relevant, such as maybe let's think about a bank account. So in a bank account we might have a current balance, and perhaps this is a deposit of some sort. In fact, let's make it negative. Let's make it a withdrawal. And so let's say we have $100 starting out and we're taking out $20. So now we want the current balance to be the previous current balance, which was 100, minus our withdrawal. So this time we're subtracting, and number 1 no longer exists. Notice how this went red. This is because the variable number 1 doesn't actually exist anymore, seeing as we changed it to a different name. So this is one of the great things about working in Xamarin Studio, is that if there's some kind of an error, like a variable that is not assigned anymore, it will turn red, so we know there's something wrong there. So we'll get the new current balance being printed out. So we'll stop the simulator and rerun it with the iPhone 5S again. And just wait for it to load here. There we go, we get 80 being printed out. Because that's the results of our current balance of 100 minus the withdrawal of 20 and the reassignment to, and that's being reassigned to current balance. Now let's just do some multiplication. So let's just say 100 times 20, current balance times, let's say this is a deposit. In fact, let's have a better real life example. Let's have a deposit and we're doing that let's say we're doing that 5 times. So let's say the current balance equals current balance plus whatever our, let's put this in brackets, whatever our deposit is times 5. So this is one of the great things you can do, is you can multiply variables by variables based on name or by number value. So let's say we're making maybe 5 deposits of 20, and we'll run this again. And just wait for it to load here. And we get 200, because we have 100 originally, so this is 200 here. We get 100 originally from the current balance, plus 5 times the deposit of 20, so that should be a total of 200. Now we can do the same thing with the divide operator. So let's say deposit divided by 5, so this should be 20 divided by 5, which would be 4, so the current balance will be 104 if all goes well. And again, we'll just wait for it to load here. And yeah, there we get 104 being printed out. So that's a great thing. We can perform many operations. There is a lot of different math you can do. Some of the functions are built into the system itself, but a lot of them deal with floats and doubles, which are a different way of representing numbers. We'll talk about those a little bit later. Now, just to prove that integer types can only be numbers without decimals, let's try and add a decimal and see what happens. So all we're going to do is we're going to get rid of this math here, and we're just going to, actually we'll get rid of that, otherwise it's going to throw us a warning, and let's see what happens. So if we stop running this and run this, here we go, it says cannot convert from type double to int. That's because with the decimal place it no longer becomes an integer. And same with if we try and give it, let's say, a Boolean value, and we try and run it. There we go, we get errors because constant value true cannot be converted to a type integer, because integers are only non-decimal numbers. As part of the tutorial, we introduced the integer type variables. Now to recap, these are non-decimal numbers that can take on the values between about 2 billion and negative 2 billion, give or take a bit, but are used instead of doubles or floats because they take up less space in memory. So they're the most common way of representing numbers that we'll see. So by now you should be able to perform basic arithmetic operations such as addition, subtraction, multiplication and division on integers, and recognize where they would be used in real life.